Today's lesson is exploring real numbers. Our objectives are to classify numbers and to compare numbers. Vocabulary, natural numbers. Natural numbers are 1, 2, 3, 4, 5, 6, goes on forever. They're like whole numbers, which that's number 2. Whole numbers, whole numbers though have 0 attached with it. And then you have integers are whole numbers and natural numbers, but also they're opposites. So now -1, -2, -3, so on. Rational numbers are natural numbers, whole numbers, integers. And then you have perfect square roots. So something like square root of 25. And fractions, 1/3. Decimals, so 0.6 with a line over it. Or so that's a decimal that repeats. Or a decimal that terminates, so like 0.31, and that's a terminating decimal. And then on the opposite side, you have irrational. So those are non-repeating decimals. That would be like 3.14 ... That would be what we call pi. Or we can have a non-perfect square number. So that would be like square root, which would be like square root of 5. And then another one would be, another thing that you need to know are called real numbers. Those are all the numbers in the universe. That would be both. Okay, we have what's called a counterexample. A counterexample is any example that proves a statement false. And then you have inequalities, a mathematical sentence that compares the value of two expressions using an inequality symbol, such as the less than. All right. This is called the less than symbol. And this is called the greater than symbol. The number that is the biggest will be eaten by the crocodile or alligator, depending on what you call it. And then you have what's called opposites. Those are numbers that are on the same distance from 0 on a number line, but in the opposite direction. So 8 and -8 would be opposites. And then absolute value is how far the number is from 0. All right, so example 1, name the sets of numbers to which each number belongs. So the numbers that we're, type of numbers we're talking about are natural numbers, whole number is integers, or rational numbers are irrational. So A is a fraction. So natural numbers are 1, 2, 3, 4, so that doesn't work. Whole numbers are 0, 1, 2, 3, 4, so that doesn't work. Integers are negatives and positive, 0s, 1s, and 2s, and 3s, and 4s. And then rational numbers have fractions in it, so this is going to be just a rational number. Because if it's a rational number, it cannot be an irrational number. 23. 23 happens to be 1, 2, 3, 4 in the natural numbers. It also is a whole number. And then you have, because natural numbers go with whole numbers and whole numbers go with integers, so we'll have integers. And since all three of those go with rational number, that would also be a rational number. All right, 0. Natural number. Does it have 0 attached? It's 1, 2, 3, 4, 5, 6, 7, 8. So that's not a natural number. But a whole number has a 0 attached, so we'll make it a whole number. Also, a whole number is an integer, so it's also an integer. And an integer also is a rational number, so that's a rational number. And then D, it's 4 and 581 thousandths. So it's a decimal, so we have natural, it couldn't be that, it couldn't be a whole, it couldn't be an integer, but since it's a terminating decimal, it's a rational number. All right, next one. are whole numbers, integers, or rational numbers. So it's only these three that we're discussing. Whole numbers, integers, and rational numbers are the only thing we're discussing today on this part of the lesson. The number of students who go on the class trip. Well, can it be a negative amount of students? No. And it cannot be a fraction amount of students, so the best one would be a whole number. You can have 0 students go. And there's no such thing as a fraction of a chance of a students. Even if you only brought your arm, you're still a whole student. The height of a door frame in your classroom. Well, it could be a whole number, but it also could be like 6.5 feet. So that would be a rational number. Our shoe size would be considered a rational number because some of you have little tiny feet, like 6s, and then you have really big feet, like 10.5. So that would be rationals. Is a statement true or false? All right, so we have, is the statement true or false? If the statement is false, give a counterexample. All whole numbers are rational numbers. Well, the whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3. Are all those rational numbers? Yes, they are. The square of a number is always greater than the number. Well, what we're used to, like 1 squared, 2 squared. So 1 squared equals 1. Oh, right there, that's a problem, because I'm guessing 1 is not bigger than 1. So right here is a counterexample to that. So there's a counterexample. If you want to do a fraction, you can. You can have half squared, which is a half times a half, which equals 1/4. And that, again, would be a good example. Okay, compare. All right, so to figure out these kind of problems, to compare fractions, you are going to have common denominators. So 3 and 6, they're not common. So what's the common denominator? 6 is. This won't change, but this one will. 3 times what equals 6 times 2. So that would be -4. All right, so we have to figure out which one is bigger. On the negative line, the number closest to the 0 is bigger. So this time, -1, 6 is closer than -1/4. So this would be a greater than sign. Less than sign. -2/3 is less than 1/6. Then you have 3/5. Well, you could turn 3/5 into a decimal, and you do that by doing this. Or you could turn this into a fraction, which, if you say this correctly, would be 6/10. And I can reduce it to 3/5. So now I have 3/5 and 3/5, and they equal each other. Order them from least to greatest. Again, you need to have a common denominator. So I have 8, 2, and 12. Well, if I did 12, 8 doesn't go into 12, so it has to be higher than 12. Well, the next number on the number line for 12 would be 24. Well, does 8 go into 24? Yes, it does. And 2 goes into 24, so it's going to be 24, 24, and 24. So this would be -10, -12, and negative negative 9. So we're going to go from the least. So which one is the farthest away from 0, because they're all negatives? So that would be this one, or negative 1/2. You have to turn it back into its normal one. And then next would be negative 10/24, or negative 5/12. And then the biggest number would be negative 3/8. Now, if you look at it this time, you have again 12, 3, and 8. But which one can you tell is immediately the biggest number? Well, the one that's positive. So I'm going to put 1/12 over on this side. So all we have to deal with is these two. So that would be 24 again. I'm going to put 24ths down here. Negative and negative. I'm going to times the first one by 8, so this is going to be negative 16, and times the second one by 3, so it's negative 15. Again, the one that is the biggest number is the least, so that would be negative 2/3, and then negative 5/8. So there's your answers in correct order. All right, let's try another one. Absolute value. Now again, absolute value means how far something is from 0. So if I look at it, how far is 12 away from 0? You're going to count it. You're not counting negatives or positives, you're just counting it. So if I looked on a number line, I would see that 12 is 12 away from 0. And then I would look on my number line again, and I would see that negative 2/3 is on the left-hand side, but it's 2/3 away from 0, so it would be 2/3. And then 0. How far is 0 away from 0? Well, there isn't any, so it would be 0. And then you have negative 3/7, 3 and 7/10, and that is to the left 3 and 7/10, so it would be 3 and 7/10. And it's always positive. Now, if I had a negative and then an absolute value, say like 12, the negative on the outside would stay, and then you would say, what's the absolute value of negative 12, which is 12, and there's your answer. All right, goodbye.